We first introduced STING, the first grid-based method, which is statistical information in the grid structure. This method called statistical information grid approach. Essentially, you can think the grid structure look like this. You got multiple layers. That means the spatial area is defined into rectangular cells at the different levels of resolution. Then these cells actually form a tree structure. That means each cell at a higher layer. Each cell actually stores a summary of the lower level, a set of cells. That means the cell at a higher level contains a number of smaller cells of the next lower level. To that extent, it forms a hierarchical tree structure. What the cell will store? The statistical information of each cell actually is calculated and stored beforehand, and then can be used to answer queries. That means you can calculate the statistical information at its corresponding set of cells at the lower layer. Okay. Then the parameter of the higher level cells, the calculation contains a bunch of statistical information, including number of points in the cell, which is a count. Okay. Then their mean, their standard deviation, the minimum value, the maximum value, and also the type of distributions. For example, whether these points form a normal distribution or uniform distribution or other kinds of distributions. So if we store these cells in a hierarchical way to process a region query, including finding clusters, we can start at the root of this grid structure and proceed to the next lower level using this STING indexing structure. That means we can calculate the likelihood a cell is relevant to the query at some confidence level using the statistical information stored in the cell. Once we are confident we need to go down, only children at the likely relevant cells are recursively explored. So it is quite localized. It could be quite efficient. We can repeat this process until the bottom layer is reached. The advantage is this structure is query independent, and the process can be easily parallelized, and we can do incremental update as well. Also, the efficiency is very good. That means the complexity is quite low, because if the K is number of grid cells at the lowest level, then the complexity is big O linear to K, while K is much less than N, the number of data points. However, its disadvantages, because you form a grid structure, you may lose a lot of details. The probabilistic nature of the higher level may imply a loss of accuracy in the lower level for query processing.